Okay, in this video we talk about f prime, sketching over to f double prime, right, the derivative of the first derivative of the second, and then we're going to come back and associate it with the original function, which in this case is called f. So I want you to notice one thing right off the bat, that there are no y tick marks. Okay, a graph does not tell you anything about the y value for either of your derivative or your antiderivative graphs. Okay, so don't worry about exactly where the max or the min values are. All you're really concerned about are the x values. Okay, so let's see, what does our graph of f prime tell us? It tells us a couple of things. Number one, whenever our f prime crosses the x-axis, that means your f graph either has a maximum or it has a minimum, right? Because that's a zero. The zero on f prime means your original graph has a horizontal tangent line. And a horizontal tangent only occurs at a max or min. So everywhere your first derivative has an x-intercept, right, a zero, your f graph either has a minimum or it has a maximum. Okay, so that's one thing that we can tell from our f graph, or from our f prime, is that your f either has a minimum or a maximum at the x-intercepts. Okay, so to decide whether it's a minimum or maximum, we're going to look at the y values. Okay, so if we have a y value that's positive, right, this is the slope. If our slope is positive, that means that your f function is increasing, right? The y values are increasing on your f function if the first derivative is positive. And if the first derivative is negative or below the x-axis, like it is here, okay, that means your function is decreasing, right? So this is a decreasing interval between -4 and -1. So if our f graph goes from increasing to decreasing, does our point become a maximum or a minimum? That's going to be a maximum value. So on our f graph, we're going to have a maximum point at -4. So let's come over here, and -4, somewhere over here along -4, I don't know where, remember, I cannot decide the y value, but I'm going to have a maximum point where x is -4. Okay, so then our next zero, if our y values go from decreasing to increasing, that means this is going to be a minimum value. Okay, so at -1, our f graph is going to have a minimum. So somewhere along this point, our f graph is going to have a minimum value. And lastly, once again, we have a positive to negative. Our slopes go from positive to negative. So this is going to be, once again, a maximum point over here at +4. Okay, so we know the x values, but you don't know the y values for your maxes and mins. Okay, so we have a maximum, a minimum, and then another maximum. Okay, so on the interval from -infinity to -4, our graph is increasing, right? So it could be anywhere. It could not cross the x-axis. It could cross the x-axis. I don't really know, but I know that the graph comes up and has a maximum, a local maximum at that point. Okay, so here's a sketch. There is a local maximum happening at -4, and then we have a local minimum happening at +1. And then we have another maximum up here at +4. Okay, now our graph doesn't tell us anything about whether it's a local max or an absolute max. Right, so this is just, right, a potential. I don't know if this is the actual graph because I can't tell what the y values are from my first derivative. I can only tell what's happening at the x values. So I know that there's a maximum value when x is 4, I know there's a minimum when x is -1, and I know there's a maximum when x is -4. Okay? So your graph could look something like that, or it could look nothing like that. But you know that there's going to be a peak at -4, and a valley at -1, and another peak at +4. Okay? So let's see if we go the opposite way. What can we decide about our second derivative from your first derivative? Well, first of all, we know where the zeros are. Okay? We know that wherever the minimum value is here from your second derivative, let's call that -2.5 about. That means over here on our second derivative graph, we're going to have an x-intercept at -2.5. Okay, likewise, if we have a maximum value here, call this 1.5. Okay, here we have another horizontal tangent line, right, where the slope is 0. That means we're going to have another x-intercept there at +1.5. Okay, so we know that those are your x-intercepts because that's where your f prime graph is 0. It has a slope of 0. So let's see, what else can we tell? What about what's happening to the left of -2.5? So over here, what is happening with our y values? Okay, the y values are decreasing to the left of 2.5, and if your y values are decreasing, that means your slope is below the x-axis, right? Our y values are negative, right? Negative slopes. Okay, and then in between, on the interval from, let's see, on the interval between -2.5 and 1.5, your y values are increasing, which leads to a positive first derivative, or positive slopes, right? And once again, remember, I don't know what that y value is up there. Okay, in fact, I don't know where it's going to be exactly. Maybe in the middle. Maybe there's some symmetry there. I don't know. So don't be too detrimental. And then, of course, after 1.5, your graph is once again decreasing in y values, which means you have a negative first derivative. So this would be a potential sketch of your second derivative. Okay, so once again, you don't know what the y values are from your graphs. You only know the x's. The x values where you have maxes, the x values where you have minimums, and the x values where it crosses the axis on your other derivative coming after you.